In our previous video, we learned what ServiceNow is and why organizations use it. But have you ever wondered what actually happens behind the scenes when you submit a request? How does your request reach the server? Where is the data stored? And how do business rules, client scripts, and Flow Designer work together? Let's find out. And how does ServiceNow communicate with external systems? In this video, we'll explore ServiceNow platform architecture, set the basics. So, let's get started. Let's start with the simplest definition. ServiceNow architecture describes how different components of the platform work together to deliver applications and business services. It defines how ServiceNow stores data, executes business logic, automates processes, and communicates with other systems. At a high level, we can understand ServiceNow through four major areas: the user interface, application and business logic, data, and integrations. Together, these components form the ServiceNow platform architecture. Now, let's understand each layer one by one. Before we talk about the individual layers, there's one important concept you need to understand: the ServiceNow instance. An instance is a dedicated ServiceNow environment, where an organization configures and runs its applications, processes, and data. Large organizations commonly separate their environments into development, test, and production instances. Developers build and test changes in development, validate them in test, and then deploy approved changes into production. When you log into a ServiceNow URL, you're connecting to a particular instance containing users, tables, applications, configurations, workflows, scripts, and business data. Now let's start from the top, the user interface layer. This is the part of ServiceNow that users interact with directly. Users can interact with ServiceNow through Next Experience, Employee Center, Service Portal, and other interfaces. Users work with forms, lists, dashboards, workspaces, portals, and many other user experiences. For example, when an employee opens an incident form and enters a short description, they're interacting with the user interface layer. But that's only the beginning. That information now travels to the application and data layers behind the interface. This brings us to one of the most important parts of ServiceNow, the application and business logic layer. This is where ServiceNow decides what should happen when users interact with the platform. Several ServiceNow features work together here. Client scripts can control behavior. Client scripts can control behavior in the browser and make forms interactive. UI policies can control whether fields are visible, mandatory, or read-only without changing the underlying data itself. Business rules execute server-side logic. The request travels from the UI to a glowing server labeled business rule. Script includes allow developers to create reusable server-side logic, while Flow Designer automates processes using flows, actions, and approvals. An employee submits a laptop request. The UI collects the information, server-side logic processes it, a flow triggers the required approval, and fulfillment tasks, notifications can then inform everyone involved. Together, these components transform a simple form submission into a complete automated business process. Now let's talk about where ServiceNow stores information. At the heart of the platform is the data layer, built around tables and records. If you're learning ServiceNow development, this is one of the most important concepts to understand. Almost everything in ServiceNow is stored in tables. For example, incidents are stored in the incident table, users are in the user table, and groups are in the group table. Provides many more tables for requests, such as tables contain records, and records contain fields. This is one of the core concepts of the ServiceNow data model. An incident record contains information, such as number, short description, and caller, assignment group, assigned state, and priority, and finally, the description. ServiceNow uses a metadata-driven architecture. It stores business data and defining information. Metadata controls layouts and behavior. This forms the platform. One particularly important concept in ServiceNow is table extension. ServiceNow uses table inheritance to allow tables to share common fields and functionality. A common example is the task table. Many task-based tables extend tasks and automatically inherit common fields and functionality. These child tables inherit fields like number and state. Incident, problem, change, and catalog task are examples of task-based tables that build on this shared architecture. This means developers can reuse common functionality instead of rebuilding the same structure for every application. This reusable data model is one reason ServiceNow can support many applications on a single platform. Now let's talk about security. ServiceNow provides multiple layers of access control to protect applications and data. At a basic level, users are associated with roles, and roles determine what functionality and applications they can access. But roles are only part of the story. ServiceNow also uses access control rules, commonly called ACLs, to control access to data. ACLs can control access at the table, record, and field level. This allows organizations to define exactly who can read or modify information. Conditions and scripted logic can make these access decisions even more granular when required. So, when a user accesses data, ServiceNow evaluates the applicable security rules before allowing the operation. ServiceNow doesn't work in isolation. In enterprise environments, it communicates with many internal and external systems. For example, ServiceNow can integrate with platforms such as Azure, AWS, SAP, Salesforce, monitoring tools, identity systems, and custom applications. ServiceNow provides integration capabilities, such as REST APIs, SOAP web services, and Integration Hub, webhooks, and other technologies. APIs allow external systems and ServiceNow to exchange data, triggering actions and keeping information synchronized between platforms. For systems inside a private network, a MEMID server can provide a communication path for supported integration and automation use cases. This makes ServiceNow a powerful workflow layer that can connect different enterprise systems and coordinate processes across them. Here's an important concept for ServiceNow developers: synchronous versus asynchronous processing. The user waits for the response. Operation complete. In asynchronous processing, the work happens separately. This allows user interaction to continue without waiting. Again, ServiceNow provides asynchronous mechanisms such as asynchronous business rules, events, and scheduled jobs. Choosing the right approach helps improve performance. Let's view a simple example. An employee submits a laptop request. Just click Submit, and it is done. First, the user interacts with the UI. The request is sent into the ServiceNow platform and processed by business logic. The information is stored in the appropriate tables. A flow can then trigger an approval process and create fulfillment tasks for the required teams. Notifications keep everyone informed. Integrations can connect external systems, and dashboards provide visibility into the entire process: request, integration, notification. At an advanced level, ServiceNow architecture goes far beyond forms and tables. Developers work with scoped applications, APIs, reusable components. Developers also need to think about application boundaries. They must consider data modeling and security, and how components interact. Performance and scalability are critical. Maintainability and integrations are also vital. Finally, we must consider security and upgradability. A good ServiceNow solution isn't just about making something work. It should be secure, scalable, maintainable, performant, and upgrade safe. We begin with our users. They access the user interface. Next is the application and business logic layer. Then we have the data and integrations, connecting to Azure, SAP, and Salesforce. Sometimes, a simple solution just works. But for true enterprise scale, we need a complete architecture. This covers security, scalability, and monitoring. Let's start with security. Then we have scalability, followed by maintainability and performance. And finally, it is upgrade safe. Don't worry, this complex process is actually quite simple.